All right, so let's go through the proof of Euclid's proposition number 27. Now, what that proposition says is that if a straight line falling on two straight lines make alternate angles equal to one another, then the straight lines will be parallel to one another. So what we want to do is kind of do a little bit of a proof by contradiction. And suppose we've got this set up, so we've got two lines and we've got a transversal coming across, and let's go with the initial assumption that alternate angles are going to be congruent. Okay. Now let's further add on the assumption that those two lines happen to intersect. So let's say that we've got a point G out here where those two lines happen to intersect. Now let's see if we can get a contradiction from this. Okay. So kind of what we look at here, we look at this angle, BEF, and we look at this angle. Well, we notice that those two are going to form a straight angle. But likewise, if we do the same thing down here, then we get that angle DFE and plus angle EFC. Those also make straight angles. Okay. So since those two things are going to be, since those two sums are going to be congruent to the same thing, then we have that the sums are going to be congruent. Okay. So what this tells us then from our initial assumption was that our interior angles being congruent, what we're able to do then with his common notion number 3 is that if we do the subtraction of those, therefore the remainders, so our angle AEF is going to be congruent to angle DFE. Okay, so we end up with this angle being congruent to this angle. Okay. Now, that's not such a big deal. It seems like everything is fine and great and wonderful until we take a look at this and we realize, oh, this is a triangle. And the setup that we're looking at is this angle out here, our angle AEF, is actually an exterior angle. So it's an exterior angle. The angle that we have here, our DFE, is going to be an interior angle. And so what happens by Euclid's proposition 16, it says that this exterior angle is supposed to be bigger than this interior angle. Well, wait a minute. We just proved that those two things are going to be congruent. So something went wrong. And the thing that went wrong was the fact that we assumed out here we had this point G showing up. So we assumed that we actually had an intersection point, and that leads to something that contradicts a proposition that we already know is true. And so what that tells us is that this point G out here, we thought it could exist. It leads to a contradiction, and so that point G really can't exist. And so if that point G can't exist, that's another way of saying that those two lines, line AB and line CD, can't intersect. If those two lines can't intersect, it means they're parallel. And so this proves Euclid's proposition 27.